in this video we are going to derive two formulas: the angle of deviation, which is represented by small delta, and the angle of prism, which is this, and the angle of deviation is this. Okay, so this is a ray diagram that is the refraction through a prism of a ray, and this is a monochromatic ray, so it's a ray like a light with single wavelength, so you can think of like a single color. So there's like, it's not a white light, okay, so that it won't disperse with VibGO. Okay, it's not dispersing with 7 constituent colors, it's a single color. Imagine this to be red, okay, for simplicity. All right, so that's what happens. This is not accurate. It's like, it's not gonna be like kind of parallel to the base. It's just how it's gonna look like. The ray gonna go there, like go with this angle and come out like this. Okay, it won't go up. That's what's the ray diagram is telling me. Okay, that's cool. Now we need to find the formula for angle of deviation and angle of prism. And the angle of deviation is basically, there's this person who's standing, and the person sees, yes, a ray is going right, and like obliquely hitting this surface, and then angle of incidence, and it refracts and it comes out like this, and he sees, or she sees, there's a big angle of deviation, and that angle of deviation is basically this delta. Okay, that is basically what small delta here means. Now there's delta 1, which is the deviation of this ray. See, there's this ray should be going like this, but then there was a deviation. Now this is R1. Cool. Now this is also R2. This is basically a naming convention. It should be like I1, but like, no, sorry, it should be like I2, but it's a good thing. Like, it's a naming convention to remember. Now we see that there is also one more deviation from here. This ray should be going there. So there's a deviation 2, which I wrote, sorry. So that's that deviation, this one, and then that deviation we can say it's also here, because vertically opposite angles are equal. Axiom of Euclid. Yes, it's a geometric axiom. Alright, so we got the angles. Now let me just remove this one. Okay, let's just, we don't want this, it's not that useful. Okay, alright. Now let's find a formula. Now I see that delta 1 plus delta 2 should give me the angle of deviation, isn't it? This is one of the things in geometry, like if you have this one, this angle A and B should be equal to, this should be equal to A plus B. Why? This is 180 minus A minus B. Let me just put it another color. This is gonna get mixed. Alright, this is 180 minus A minus B. Now this one should be 180 minus A minus B. That's right, plus X. Okay, this is X is equal to 180, because it's 180, right? This should be 180 when we add up these angles. See, 180 cancels, and X is equal to A plus B. See, that's how the derivation goes. So that's what's happening over there. Let me just take my lasso cut and remove these. Okay, that is amazing. Okay, so that's what's happening. Alright, let's derive then. Okay, why is it still in lasso? Okay, let's skip. So now we see that delta 1 plus delta 2 equal to our angle of deviation. Now let's just don't bother about this. Okay, cool. Now let's see, what is delta 1 plus delta 2. What we can see here is that, I know it's getting crowded, but this is basically I2 and this is basically I1. I hope you're understanding, right? Vertically opposite, you can see it. Yeah, there are like these two angles are vertically opposite to give that I1 is equal to delta 1 plus del R1. Now we need to find what's delta 1. So basically delta 1 is equal to I1 minus R1, right? Now delta 2 is equal to I2 minus R2. Now let's substitute. So basically this is the entire formula. Okay, this is what you get. Now there's one more thing we can add to this formula, that is R1 plus R2 is equal to A. That is the angle of prism. Now why is that? Let's find that out. This is basically the entire formula, okay, that pretty much. But if you want to like relate this A to this, you can do that. All right, let's find A. Okay, so let's put some points, shall we? Now what color should I use? Let's use green. This is P, this is O, Q, this is gonna be M. Okay, let's put those as our names. Okay, for these points, these vertices. Okay, so what are we gonna deal with? Okay, I see that this is 90 degrees, and I see this is also 90 degrees. So doesn't that mean this thing should be also 90 degrees? Okay, I know it's getting crowded, please understand. So this is 90 degrees. Cool. Okay, so what are we seeing? There's a quadrilateral, right? A P O Q, and I see there are two 90 degrees, so 180, adding up the 180 now, and there's angle A and angle O. We need to somehow find angle A. Now what other thing I can find that in triangle PQO, O is also though. Now let's see, R1 plus R2, that's giving me, and plus O gives me 180. Now this entire thing, this entire quadrilateral APQO is 360. If I subtract these 290 degrees, I'll get 180. Okay, let's just write it down. That's my idea going forward. Okay, alright, going forward. Now let's put that idea into reality. A quadrilateral. Okay, guess this shape to be a quadrilateral. Okay, so in quadrilateral APOQ, just consider this one. Consider triangle, quadrilateral APOQ. You see that there's angle A. Definitely there's angle A. There are 290 degrees, which gives me 180 degrees. And there's angle O, gives me 360 degrees. Now I find out angle A plus angle O is equal to 180 degrees. Cool. And I find that angle A should be equal to 180 degrees minus angle O. Now amazing. Let's consider triangle PQO. With that, okay, let's see, angle R, so R1 plus R2 plus O is equal to 180 degrees. Now that's angle O, right? So what do I find? R1 plus R2 is equal to 180 minus angle O. So what is 180 minus angle O? So I find that R1 plus R2 is equal to angle A. Therefore, we can just rewrite our formula for angle of deviation to be, therefore, it's I1 plus I2 minus A. Alright, that is basically angle of deviation formula. Wait, okay, sorry. Okay, that is basically the derivation. So what I did is I already found the formula. Now I know that R1 plus R2 should be A. It's like given in the syllabus. So let's find that out. Now you could have like found it by just seeing that angle O is equal under to 90 degrees. It's just it was my guessing, right? So it worked out. So yeah, that's my formula. Now let's do a simple question that with A is equal to R1 plus R2. Okay, let's do a question related to it. All right, cool. Now this is the ray diagram. I drew it for you all. Okay, so that's what's happening. There's a incident angle of 25 degrees with the normal, and the refractive index of glass is 1.55. Now the angle of prism is equal to 30 degrees. This is going to be very useful. Let's write given. Cool. Now, what the question is saying is to find R2. That's basically the incident angle to the normal with the interfere of what? With glass and air. That's right. It's right. Glass to air surface on the side opposite where the ray enter the prism. Yeah, it's basically what it's saying. So to find R2, that's the question. And we are given some sign values. Cool. So these sign values are gonna help us a lot. Cool. All right, so let's write Snell's law quickly. That is sine I by sine R is equal to n2 by n1. What is my n2? That is my ng. So let's just rewrite sine 25 by sine R. I don't know. That's my sine R1. Sine R1. See, that's my sine R1. Now that's my ng. What is my n1? That is 1 because it's air, and the air's refractive index is approximately 1. It's not 1. We're just making our calculation easier by just saying it's 1. It's pretty close to 1, by the way. Okay, now let's just rewrite sine R1 is equal to sine 25 by ng. So let's see what sine 25, that is equal to 0.422 by 1.55. so if you do the calculation, you will get approximately 0.27, and its sine value is given. If it's sine this, it's, I think there's this something like this. I think, why did I do this? Okay, there's a -1 actually. So if that's the case, if you have this, and if that's the reason, you will find that if you get that 0.27, you find that angle is 15.8. I don't know how that makes sense. I didn't learn how to find that, but it's given in the question, so let's use it. So my R1 is 15.8 degrees. Amazing. Now let's see. A is equal to R1 plus R2. A is 30 is equal to 15.8 plus R2. R2 is the one we need to find. Its value is not given. So it's 30 minus 15.8 is equal to R2. 30 minus 15 is 15. 15 minus 0.8 is what? 14.2 degrees is equal to R2. So therefore R2 is equal to 14.2 degrees. So that is our answer, and I hope this was a good exercise. Alright, so that's all for today's video, and I hope you all learned something new today. So thanks for watching. Bye.